And I need, well, let me go back here. That's our objective today. I forgot to turn this on for a second to find the values of the trig ratios for acute angles of right triangle. And we're talking about right triangles right here. Okay, so I need you to know which side is always the hypotenuse. I get a few students every year that can't ever get this straight. How many of you know what a hypotenuse is? Okay. How do you determine a hypotenuse of a triangle? Which side's the hypotenuse? Opposite what? Opposite of the right angle. That's how I do it. Okay? Here's the right angle, opposite from it. Some people say it's the longest side. Well, it is. It's always going to be the longest side of a right triangle. But sometimes that can be hard to determine just by looking at it. So I always say the easiest way to find it is opposite of the right angle. And the other two sides, the two sides that come together to form the right angle, are called the legs. And we're going to call one of them adjacent, one of them hypotenuse here. I mean, one of them adjacent, one of them opposite in just a second. But those are the parts of a right triangle. One other thing I want to note, when we label triangles, we usually use capital letters to name the points or the vertices. What do we use to name the sides? Huh? What was that you said, Jack? Lowercase letters. We do. We could name like this hypotenuse, we could name it side AB. We can use it with two capital letters, the two vertex letters, but that's kind of long. So what we do is we name it with lowercase letters of the angle opposite of it. So opposite of C is this angle right here. What would this one be? And this one? B. Because you just go opposite of the angle. So opposite of little a is big A, opposite of little b is big B, right there. Okay, so you need to know that as well. Okay, now, adjacent and opposite sides are going to be the legs. But notice that they switch. Up here I have adjacent, opposite. Over here I have opposite and adjacent. Okay, how do you tell which one's which? Well, it depends on which one is your reference angle. Okay, I've marked angle A up here as my reference angle. Okay, what side is opposite of angle A? Well, it's this CB down here, right? And so we call that one the opposite. Hypotenuse is always going to stay the same, isn't it? It's always going to be opposite the right angle. Okay, and then adjacent. What does the word adjacent mean? Rhett, what does the word adjacent mean? No, the word adjacent does not mean opposite. Opposite means opposite. What does the word adjacent mean? Who knows what the word adjacent means? Okay, it means next to. That's exactly it. It means next to something. So here's angle A. There's two sides actually that are next to angle A, right? But one of them's the hypotenuse, and the hypotenuse is always the hypotenuse. So the side next to angle A that is not the hypotenuse is the adjacent side. Now notice down here it switches because I'm using angle B as my reference angle down here. So if angle B is my reference angle, opposite of it would be this side, and adjacent to it would be this side. Okay? Any questions there? Okay, so, you guys still copying it down? I get a lot of students that get confused on which side's opposite, which side's adjacent. Just think about it. Opposite is opposite, adjacent is next to. Hypotenuse is always the hypotenuse. Okay, now, this next slide. Now here, don't write anything down on this next slide. I'm going to give you a minute longer to write this stuff down. Okay, right here. Okay, I don't want you to write anything down. Just watch. Everybody just put your pencils down for a second. Just watch this right here. I want you to understand this concept. But you don't have to memorize it or anything like that. You just need to understand the concept right here. Okay, I've got two triangles right here. What do you notice? What's similar about these two triangles? They have the same angles. Okay, 22.6 degrees, 67.4, and 90. 22.6, 67.4, and 90 on both of those triangles. But they're different sizes. Why are they different sizes? Because they're scaled, right? Do you remember what we call two triangles that are the same shape but different sizes? Similar triangles. Congruent means they're exactly the same. Everything's exactly the same. Okay, but this one has the same angles, but not the same length of sides. But so they are similar triangles. They have the same proportions. They're scaled, like Courtney said. Okay, like when you make a model airplane, you scale everything down. So 1 inch equals 1 foot on the real plane, right? Or 1/4 of an inch equals 1 foot on the real airplane, or something like that. And you stay consistent, so everything is proportionally the same. Okay. Well, I'm going to have 3 ratios. What's a ratio again? Comparison of 2 numbers by division, right? In this case, I'm going to compare lengths of sides. Okay. And I'm going to show you on this triangle, the smaller triangle, if I take on the 22.6 degree angle, if I take opposite side, which is 5, over the hypotenuse side, which is 13, I have side opposite is 5, hypotenuse is 13, I get 0.385. Well, if I come to this bigger triangle, and I go from the 22.6 degree angle, I go opposite side, which is 15, over hypotenuse is 39, I still get 0.385. 15 divided by 39 is 0.385. Notice that the ratios are the same. In fact, I can make, as long as I have a 22.6 degree angle and a 90 degree angle and a 67.4 degree angle, it doesn't matter how big the triangle is. If I took the opposite side divided by the hypotenuse side of the 22.6 degree angle, I would get the same number every single time. Yes? Yes, they are. We're leading into it right here. Okay? Then we're going to look at this one down here. This time I'm still with the 22.6 degree angle. I'm going to go side opposite over side adjacent. Side opposite of 22.6 is 5. Side adjacent is 12. And over here I have 15 and 36. Well, notice both of them. 5 12 equals 0.416. 15 36 equals 0.416. They're the same. Or the third ratio I can do is the side adjacent over side opposite. Side adjacent is 12 over hypotenuse is 13. And 36 over 39, they're both, can't see it right there, but they're both 0.923. So the ratios are the same no matter how big the triangles are. If the angles are the same, then it's going to be the same. Well, the Egyptians actually figured this out 300 BC. That's 2,300 years ago, you guys. And they figured out this, and they found it out of necessity. They were trying to divide up land, and if they had unknown lengths, they could use two things that they knew and figure out the third thing that they needed to know by writing down an equation and solving it. Okay, so trigonometry has been around for 2,300 years because of necessity. And those 3 ratios we just looked at, Brock was exactly right. These are 3 of the trig ratios, the 3 common ones. Sine, cosine, and tangent. Now don't write this all down yet. I'm going to tell you which part to write down. I want you to write down the green part, because that's the abbreviation. So before you write it down, everybody look right here, just for a second. Sine. It's not sin, because we abbreviate it. Looks like sin, but we say sine, okay? So sine equals opposite over hypotenuse. This is how we abbreviate it. Sine theta equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. Okay, write these down. Okay, so, by the way, theta, you guys, this little thing right there, that's a letter in the Greek alphabet called theta, and we use it in math, usually with angles to name it's our variable that we use for angles. So just like x and y we use in algebra, we use theta in trigonometry. Okay. All right. So next right here. Find the value of the sine, cosine, and tangent for angle B. I'm going to pause this right here. I want you guys to do this. Okay? I'm going to come around at your tables and see what you got. Red, I need you to move to a table with someone else while we do this right now, because I want you guys to compare your answers. I'm not going to give you the answer. You guys have got to come up with them. Okay? Okay, so here's a cosecant, secant, and cotangent. These are the other 3 trig ratios. If you flip sine over, you get hypotenuse over opposite, and we call it the cosecant. This stands for cosecant. See, cosecant. The theta. I talked about theta. Theta is the variable. Stands for an angle. They're Greek letters is what they are. We just use them in mathematics as math terms, but they're Greek letters. Letters in the Greek alphabet. I don't know, maybe the Latin alphabet too. I don't know. So, but yeah, when you see those college fraternities, they're just naming them after Greek letters in the Greek alphabet. Okay. So we got these down. Hey, so if I give you guys a cosine, if I give you guys, if I give you a cosine, what's the reciprocal of cosine? Which function is a reciprocal cosine? Secant is. Secant. It's 1 over the cosine, right? Reciprocal of tangent is cotangent. So cotangent is 1 over tangent, and cosine secant is 1 over sine. Okay? I don't know, but that's how I remember it, because I just remember the cos don't go together when you're talking about reciprocals. I know. I did too. But that's how I remember now. Cosecant and sine go together, and secant and cosine go together. So the cosine and the cosecant do not go together. That's how I remember that. And cotangent and tangent, the two tangent ones go together. Okay? So yeah, I don't know. You guys, these names, I'm guessing these names are either Latin or Greek names. And they have something to do with in that language how they name the ratios. Okay, you guys, number 1, if cosine of theta equals 3/4, find secant of theta. You should have the answer by now. When you have the answer, raise your hand, Joe. When you have the answer, raise your hand. You should have it by now. When you know the answer to if cosine of theta equals 3/4, find secant of theta. What is the secant of theta? Kristen, what is it? 4/3, because cosine and secant are reciprocal functions. Okay, good. What about number 2? Raise your hand when you got the answer to that one. Alex and Joe, raise your hand when you got the answer to this one. You don't need a calculator. You can use your calculator if you want. But I don't know what the answer. Give me a calculator answer. It's probably close to that. How did you get that? 1 divided by 1.345. Is that how you got it? You guys, sine is the reciprocal, so it's just going to be 1 over 1.345. So whatever that is, it's going to be about 0.7, somewhere around in there, 0.8. Go 1 divided by 1.345. Okay. So you did it right. Okay. So these are examples of using the reciprocal functions. So you need to know those. Okay. Hey guys, these are the basics, trig functions. Red, listen carefully to this. If you don't get this down, you'll be lost the whole time we're doing trigonometry. Make sure you guys get this part down. Okay? If you're lost already, raise your hand. Can't be lost already.
Mallory's lost.
I guarantee you one thing about Mallory I know. She's going to go home and study this, and she'll have it done next time, and she'll know it. Okay. Cassidy's one of those. Yeah, it's genetic for Cassidy. I'm just kidding. No, Cassie gets math though. Cassie probably paid attention to math. Okay. Yeah. Yeah. You guys can all tell Cassie can't speak English, but he can speak math. I'm just kidding, Cassie. Just giving you a hard time. All right. Okay. Now, hey, you guys, I don't know if you remember this. This is something you learned in geometry a long time ago. You learned about 30, 60, 90-degree triangles. I'm just showing you this because there's something on your assignment about it. Okay. You guys, a 30, 60, 90-degree triangle is half of an equilateral triangle. Did you catch that? That's important to know. A 30, 60, 90-degree triangle is half of an equilateral triangle. An equilateral triangle has 60, 60, and 60-degree angles, right? And all three sides are the same length. Well, if you cut it in half, you get a 30, 60, 90-degree triangle. And since this side was the original side, and this side was the side that was cut in half, because this length right here is half of the whole length, then we know that the short leg of a 30, 60, 90-degree triangle is half as much as the hypotenuse. And then the long leg, you take the short leg and times it by the square root of 3. You'll always get it. So if I had something like this, if I had a 30, 60, 90-degree triangle, if that was 2, what would this be? And what would this be? Look at this thing up here, you guys. Thank you, Rhett. See, Rhett is naturally good at math. He's just not naturally good at listening sometimes. When he listens, he gets it, right? Okay. You're going to work on that listening part, right, Rhett? Okay, so right here, you guys, this is 30, 60, 90-degree triangle. If this is 5, what is this? What is this? Huh? It's not square root of 3. Look at the pattern, you guys. Huh? 5 square root of 3. Thank you. You guys, whatever the hypotenuse is, the short leg is half of that, and the long leg is the short leg times the square root of 3 every time. All right. This one, you guys, this one. Okay, I'm going to write down 12 right here. What's that? 12 square root of 3. It's not that hard. All right, see? You got that. Okay, now, you guys, just as a 30, 60, 90-degree triangle is half of an equilateral triangle, 45, 45, 90-degree triangle is half of what? It's half of something. What is it half of? What shape is this shape half of? Oh, thank you. It's a square. If you put another one right here, okay? I feel like I'm not asking that hard of questions. You guys are struggling with it, so half of a square. Okay. All right. So you guys, if a side of this is 10, what's this side? 10. And what's this side? 10 square root of 2. It's always, the hypotenuse is always the side of a 40, on a 45, 45, 90-degree triangle, whatever the side length is, the hypotenuse is that length times the square root of 2. Both sides will be the same? Yeah, because it's half of a square. A square has 4 equal sides. Okay? Okay. Now, you guys just see how much smarter you guys are. You guys didn't get any smarts today until you came to math class. So.
Actually, I learned the cha-cha.
Okay. All right. So cofunctions. Okay. Okay, all eyes right here. Okay, listen. Alex, expect you to get this. I'm going to ask you a question in just a second. Okay. You guys, two angles that add up to 90 degrees are complements. Like 30 plus 60 is 90 degrees. Those are called complementary angles. Do you remember that from geometry? Yeah. So what's the complement of 20 degrees? Which one is it, Aaron? 70. 20 plus 70 is 90, right? Okay, now just raise your hand on this one. Don't say it out loud. What's the complement of 2 degrees? Raise your hand when you know. Alex, what is it? $88. 88 plus 2 is 90, right? Okay. What's the complement of 72 degrees? When you know that, raise your hand. Okay. Okay, what is it, everybody? Brock. 18. 72 plus 18. Now, here's the cool thing, you guys. It doesn't matter what I take. If I take two complementary angles and I take the sine of one and the cosine of the other, they're always going to be equal. We call these cofunctions. Sine of 2 degrees is equal to the cosine of 88 degrees. And you know what? We can switch them around. Sine of 88 degrees is equal to the cosine of 2 degrees. Every single time. Okay? They're always equal. We call these cofunctions. Now, besides sine and cosine, the tangent and the cotangent are also cofunctions. So I can take the tangent of two complementary angles and the cotangent of two complementary angles. I mean, tangent and cotangent of two angles that are complementary, and they're going to be equal to each other. Okay? And the other one that works is cosecant and secant. So if the angles add up to 90 degrees, and you take the cosecant and the secant of each of them, they're going to be equal. We call those cofunctions. Okay? Any questions there?
Wait, so does secant include cosine also together?
No. Reciprocals, what's reciprocal is not the same thing as cofunctions.
But because like tangent and cotangent, they're reciprocals, right?
But they happen to be reciprocals and they happen to be cofunctions as well.
Okay,
Yeah.
oh, I was thinking
Cosecant and secant are not reciprocals, but they are cofunctions. And sine and cosine are not reciprocals, but they are cofunctions. Okay? Any questions here, you guys? Okay, you have an assignment. There it is. Okay, so the assignment that we went over today is due next time, right? This assignment is due Monday. Yeah.